Welcome back programmers. In the part 2 implement machine learning. This is the 15th video of TensorFlow series. All video link is in the description, check out now. So in the first part we learn all of these 5 chapters, and in the second part we are gonna learn analyze data with statistical regression, and we are gonna learn neural network, images and recurrent neural network RNNs. So first we are gonna explore the different types of statistical regression, including linear regression, polynomial regression and logistic regression. So we are gonna see all 3 regression. So let's begin. Chapter 6, analyzing data with statistical regression. So we got 4 types of linear regression available in here: linear regression, polynomial regression, binary logistic regression and multinomial logistic regression. So we already talked about the linear regression, so we just have to fit a straight line to the points in a data sets. You can see in this picture, this is the data and we need to create the straight line of this data, and the equation of linear regression is y equal to mx plus b. So in the today's section we are gonna talk about linear regression and how linear regression works. I know I already talked about lots of video on linear regression, but this is the linear regression with TensorFlow. Linear regression, fitting lines to data. Searching through your grandfather's attic, you find a mint condition first issue of Commander Warspeed's Journey into Space. This rare comic book may be worth many thousands of dollars, so you decided to sell it. But how much should you ask for it? As online search provide 40 selling price that range from the less than 5,000 to more than 10,000. You can see in this picture 5,000 to 12,000 price. This is the range price, not the actual price. We don't know the real price of the comic, but the range price is to 2,000 to 12,000. And here is, you can see this 1980, 95, 1995, 2000, 2005 and 2010. And by year and by price, you can see this data. When year is 1985, the price is 6,000. When year is 1919, so the price is like 4,800 something. So computing the average selling price would be easy, but you want to know whether the price is rising or falling and by how much the price is rising or falling. To find a good selling price, you decided to approximate your data with a line that indicates the change in the book's price over time. This process is called linear regression, and the dashed gray line figure 61 identifies the general trend of the comic book price we already saw. The first step in TensorFlow training involves choosing an initial expression for the model. For linear regression, this decision is easy. The model is a line whose equation is y equal to mx plus b, where m is the line slope and b is the y-intercept, the y value when x is equal 0. b is y-intercept, means y value when x is 0. The goal of a linear regression is to determine m and b so that the resulting line best approximate or fits the set of the points. The loss is also simple to compute. If the graph contains the point x and y, the difference between the system and the model is y minus mx plus b. It means y minus model, and the model is y equal to mx plus b. Now if you are confusing, just check out my linear regression video, link is in the description. In ML application, value of the loss should always have the same sign. You can make sure all of the loss value are positive by computing the square of the error at each point and take the average of the error value. If there are n points, you can compute the loss without the following equation. You can see the following equation is this. Now don't be silly, you don't have to remember this equation. You have to just write this code: loss equal to tf.reduce mean tf.pow model minus y and 2, and this is our model. Now if you don't want to write this model, you can just say model equal to mx plus b Having obtained an expression for the loss, the next step is to create the optimizer to minimize the loss. As the optimizer does its works, it will be update the variable m and b, thereby obtain a line that best approximates the changes in the comic book price over time. And you know how these work and what is gradient descent optimizer, so I'm not gonna talk about optimizer now. Now let's jump into the code. So let's first import the TensorFlow and NumPy and PyPlot for visualizing the data. Now let's create the n equal to 40 because we need only 40 data in your x and y. So let's create x equal to, I'm gonna use the random value because we don't know the actual price and the actual data of that comic book, so we are gonna use the random value. So let's create x equal to np.random, or you can use line space too. Let's use line space. You can see in here I just use the xy and xy is line space, and I just create the noise of the xy random value. Let's change the n equal to 50. You can see in here this is our data. I just use the scatter and this is our data. We need to create the straight line of this data. So let's create the placeholder x and y equal to tf.placeholder. Now let's create the w and b, which is the weight and bias. And let's define the learning rate equal to 0.01 and training epochs equal to 1000. And then I just created my model equal to tf.add tf.multiply, simply mx plus b. And then I just created the cost function, which is this cost, or you can say loss. And then I just create the optimizer and init, which is the global variable initializer, and optimizer is for minimize the loss. Then I'm gonna open session as says. First thing first I have to use this init. First I have to run this init. Now I'm gonna take the for loop epochs time. You can see I am gonna run this epochs at 1000 times. So for epochs is range of training epochs. Now training epochs is 1000. Now I'm gonna run the batches. So I forgot to define the batch. So batch is equal to n, and then I'm gonna create the another for loop for batch. So this single epochs run single batch time for batch in range of batches, and then simply I'm gonna run the optimizer ses.run optimizer, and then simply I'm gonna just print the last m and b value, or even you can print the epochs. And let's run the epochs too. And yes, don't forget to feed the dictionary because we use the placeholder in here. You can see I'm getting the output, and this epochs is the value how many times I run this w and b in here. You can see every time this run I got the different output of w and b. So I don't want all of this, I just want the last value. So I'm gonna use the training cost, weight and bias equal to cost w and b, and then I just plot all of this value. You can see red is the original data and the blue fitted line is our plotted predicted value. So that's how you can use the linear regression in the TensorFlow. If you use the linear regression code from the book, you can see the different code in here because this book authors use the different technique to use the linear regression. You can try it too. So in the next video we are gonna use polynomial regression, fitting polynomials to data. So that is it for today's guys. In the next video we are gonna use the polynomial regression. And if you like this video, just like this, share this video to other programmers, subscribe to my YouTube channel, hit on the bell icon so you'll never miss my latest updates, share this video, comment me for the next video. See you guys in the next video. Thank you.